All right, so in this presentation, I'm going to go over these really big questions. So how do we really know if a scatter plot has a linear relationship or not? Which leads to, should we use a linear or nonlinear regression model to represent data? So really, why are we making residual plots in the first place? So a quick review. If you want to create a residual plot, you first graph the original data. You then find the regression model. Specifically, for the sake of this activity, we're doing a linear regression model. Then using the linear regression model, you calculate each of the predicted data points. And then you calculate the residual for each data point. So what actually happened minus the prediction of what might happen. You then graph the x values and the residuals, which look something like this. So moving forward, when you look at a scatter plot, it appears, so if you look at this scatter plot here, it appears to have a generally linear shape. So my big question is, does it actually have a linear shape? And we're just going to keep looking at the residual plots to come up with that. So this has a generally linear shape. And then when you graph the residuals, you see that it has kind of a random or scattered or no pattern residual plot, right? The residuals are kind of everywhere. When you look at these data, it appears to have a nonlinear relationship. So this one has a little bit more of a curve, right? Generally speaking, this follows a curve. So if I were to draw the linear model, which might be something like that, the question is, does this model actually help predict these data? Well, if you calculate the residuals, you'll take a look at the scatter plot, and it has a little bit more of a pattern. It kind of curves itself also. Looking at this one, this scatter plot, it might be a little bit less obvious. Maybe you can tell if it's curved or straight, but I definitely can't. So maybe this linear model kind of, maybe it's linear, maybe it's nonlinear. And so when you look at the scatter plot of the residuals using the linear model, you see it also has kind of a curve or a pattern to it. And so the big question is, how do we know if a scatter plot is linear or not? What we do is we look at the scatter plot of the residuals, and if the residual plot has no pattern, then the linear model is a good fit for the data. Should we use a linear or nonlinear regression model to represent the data? So taking a look at this first one, this residual plot has a pattern to it. So when it has a pattern, we actually know that the linear model is not a good fit. And then if the residual plot is scattered or it has no pattern, then the linear model is a good fit. So if a scatter plot has a pattern, then the linear model is not a good model for the data set. If the scatter plot has no pattern, then the linear model is a good model for the data set. So quick review, when we look at this one generally speaking has a linear model, right? Generally speaking, it follows kind of a linear path. This one doesn't, it obviously curves, and therefore its residual plot also curves. This one also curves, although we couldn't necessarily see it. And so the residual plot shows us that. So big conclusion, if the residual plot is scattered, then it's a good, linear model is a good fit. If the residual plot has some sort of pattern to it, then the linear model is not a good fit.